All right, so we'll look at a three-dimensional minimization problem to where the simplex method really has its benefits, right, with three or more variables. Otherwise, you could use the method of corners if you only had two variables. All right, so for the minimization problem, this is a standard minimization problems, all greater than or equal to, right? So the first step is to list out your table. All right, so our constraints, we have a 1x, 2y, 2z, our constant is 10, our 2x, 1y, 1z, 24, 1, 1, 1, 16, and then for the cost, we've got the 6, 8, 4, and 0. Okay, right, so we said that we can convert this to the dual maximization problem by doing a transpose, right? Changing these rows to become columns and changing our variables to u, v, and w. All right, so the column 1, 2, 1, 6 becomes row 1. And then 2, 1, 1, 8. 2, 1, 1, 4. And 10, 24, 16, and 0. All right, now, so we said that this is the dual maximization problem, meaning that we have this profit function 10u plus 24v plus 16w is subject to u plus 2v plus w less than or equal to 6, 2u plus v plus w less than or equal to 8, 2u plus v plus w less than or equal to 4. Okay, so now we can solve the this dual maximization problem just like what we've done in the previous videos with the standard maximization problems. We introduce our slack variables. U plus 2v plus w plus x equals 6. 2u plus v plus w plus y equals 8. 2u plus v plus w plus z equals 4. And then subtracting the u, v, and w from both sides on the profit function is negative 10 u minus 24 v minus 16 w plus p equals 0. And now we have, writing this as a matrix, 1, 2, 1, 1, 0, 0, 0, 6, 2, 1, 1, 0, 1, 0, 0, 8, 2, 1, 1, 0, 0, 1, 0, 4, and negative 10, negative 24, negative 16, 0, 0, 0, 1, 0. Okay, so we take our most negative entry in that last row. We check the ratios, 6 divided by 2, 8 divided by 1, and 4 divided by 1 is 4. And by the way, if you get a ratio that's the same, like if you get 2 3s, then it doesn't matter which one you choose. All right, but here we only have 1 3. All right, the smallest ratio is 3, so we're going to pivot around that entry there. So we are going to multiply row 1 by 1/2. 1/2, 1, 1/2, 1/2, 0, 0, 0, 3. Everything else stays the same. right, so now we want to get everything else in that column to be 0. So we want all of these to be 0 right there. Okay, so we're going to take row 2 minus row 1, row 3 minus row 1, and row 4 plus 24 times row 1. So row 1 stays the same. So row 2 minus row 1, 2 minus 1/2 is 3/2, 1 minus 1 is 0, 1 minus 1/2 is 1/2, 0 minus 1/2 is a negative 1/2, 1 minus 0, 0, 0, and 8 minus 3 is 5. And now same thing with row 3. Row 3 minus row 1, 3/2, 0, 1/2, negative 1/2, and then 0, that's a 0, minus 0 is 0, 1 minus 0 is 1, 0, and then 4 minus 3 is 1. Okay, and then R4 plus 24, R1. I'll do some scratch work down here at the bottom. All right, 24 times row 1. 24 times 1/2 is 12. 24, 12, 12, 0, 0, 0. 24 times 3 is 72. So 2, 0, negative 4, 12, 0, 0, 1, 72. All right, so now we look at our last row. If we still have negatives, then we keep going. So we only have one negative, so we'll work with this third column. And we look at the ratios. 3 divided by 1/2, that's 6. 5 divided by 1/2, that's 10. And 1 divided by 1/2, that is 2. So we'll take this 1/2 in the third row as our pivot. And so we'll need to multiply row 3 by 2 to make that become a 1. Everything else will remain the same. So we're multiplying by 2 in row 3, so that's 3, 0, 1, negative 1, 0, 1, 0, 1. And now we want everything in that everything else in that third column to become 0. So we want this 1/2 and the 1/2 and negative 4 to become 0. We'll do that by taking our 1 minus 1/2 R3, row 2 minus 1/2 R3, and row 4 plus 4 times row 3. Row 3 stays the same, so I'm going to go ahead and write that out. All right, and then R1 minus 1/2 R3. I'll do some scratch work down here at the bottom. All right, negative 1/2 times 3, so that's a negative 3/2. 0 minus 1/2 plus 1/2. 0 minus 1/2. 0 minus 1/2. 1/2 minus 3/2 is a negative 1. 1 plus 0 is 1. and that's 0, that's 1, 0, -1/2, 0, and 3 minus 1/2 is 5/2. Okay, R2 minus R1/2, R3. That is -3/2, 0, -1/2, 1/2, 0, -1/2, 0, and -1/2. 3/2 minus 3/2 is 0. Then we have 0, 0, 0, 1, -1/2, 0, and 5 minus 1/2 is 9/2. And then R4, 4 times R3. Times R3, that's going to be 12, 0, 4, -4, 0, 4, 0, and 4. And we've got 14, 0, 0, 8, 0, 4, 1, 76. So after going back through my work, you may have already seen this and been scratching your head. When I went back and multiplied 2 times row 3, I didn't multiply these 1s. So these should have been 2s. 2s here. And so right here, minus 1/2 times row 3, right? These should have been -1, -1, which is -1, which is 2. So instead of, so a -1 here and a 2 there. Same thing here. All right, this should have been a -1. This should have been a 4. Let me just erase these. All right, so we've got, let's see, this was a -1, 0, 2. This was a -1, 0, 4. And then my row 4, after multiplying by 4, this should be an 8. These should be 8s. I'll change these 2 numbers here. As you can see, very easy to make a mistake. Be very careful, stay very organized in your work, so that way you can catch these mistakes. All right, so we have our solution here. Now remember what the variables are, u, v, and w, and then x, y, and z. All right, so what will minimize the cost, right? We look at the bottom row for the entries x, y, and z. All right, so 8, 0, 8 will be the solution, the optimal solution, which gives us a minimum cost of 80.